it was requested we do a little bit of capture recapture. So you want 100%. That's ambitious, but yeah, you can definitely do it. Doing through okay, yeah. For today, I thought we'd do a little bit of recapture and recapture, sorry. Literally just 4 questions, because once I teach you the method, it's pretty much the same thing all the time. It's not too bad. And then I actually did a really interesting question on the Year 11 mock that we did at the school I teach at. And there was a really good question on it. It's a proof. It's really interesting. Well, I say interesting, but there's a bit of a trick to it, so I want to see if you guys are capable of doing it. And then there's a few of the kind of tricky questions again, so I figured it might be quite good. It's a mix of calculator and non-calculator. So, with capture recapture, it's always the same kind of method that you're going to use. So what they do is they take a sample, they mark them, they put them back, and then they take another sample and see how many have the marks. So, this is how you're going to lay it out. It says here that Bhavna takes a sample of 30 beads from the bag. So she's taken 30. I'm just going to write 30. Now this is 30 out of the total number of beads that are in the bag. Right? And she puts them back. She then mixes them all up and takes another sample of 30. So, and she sees that 4 have the cross on it, have the little markings on it. So that's how you want to set up every single capture and recapture question. So again, this is the original sample size, 30. Divided by the total amount, again, because she's marked 30 out of the total amount of the beads. Then when she takes out another sample of 30 here, that's where this 30 comes from, only 4 have been marked. So the reason why this works is that the proportions should stay the exact same, right? She's marked 30 of them, so that means that should still have the same fraction. And then all you need to do is work out what x is. So you can mix this all up, so x is just going to equal, if you rearrange this, 30 times 30 over 4, which should be, so that would be, what, 900 over 4, which is 450 over 2, which is 225 beads. Okay? Just so this can come up in non-calculator and calculator, just so you guys are aware. Any questions about that? Is that all okay? In terms of the assumptions, this is a bit that a lot of students don't actually get quite right, even though what you're saying might be technically true. Good, yeah. So all you need to do is always write. This is the one where if you write this, you'll always get the mark. You always say that none of the marks have rubbed off or fallen off. So none of the marks have like rubbed off or fallen off. Okay? That will always get you the mark in every single capture recapture question. So you can just use that. Okay? So the assumption is that none of the marks have gone missing, they've rubbed off, fallen off, or been removed somehow. Okay? So again, I said we're going to do about 3 of these. That's weird, it says total. Anyways. So we're going to do about 4 of these. Again, so Carlos wants to find an estimate for the number of ants in a colony. This is, by the way, how they actually do it in real life. So he catches 60 ants from the colony and marks each one with a die. He then returns the ants to the colony. A week later, they catch another 60 ants and 8 are marked. So again, he catches 60 out of the total number of ants in the colony. And when he takes a sample of 60, only 8 have the marking. So we do the exact same thing again. Okay? So x is going to equal 60 times 60 over 8. Okay? And you do the same thing again. 3,600 over 8. Okay? Which, how many kind of 8s go into 36? You can just get, it should be 450. So half it 3 times. Okay? So it's the exact same method over and over again. Whoops. And, oh sorry, it says also write down an assumption. Again, none of the marks have fallen off for the 3rd mark. Okay, fairly easy. No marks have fallen off. Again, you always get the mark if you just write that for the assumption. No ant spread. Oh, as in like the actual population didn't increase. Interesting. So in the time it took, so wait, a week. So in a week, did any more? You know, technically you would be right. If this was a science paper, I would say yes. But in a maths paper, I'm not sure if they would give you the mark for that, even though you are technically right. That's a very good point. If this was like a biology paper, I would say you would definitely get it, but I don't know if they'd give it for maths. Although it is a valid suggestion. I would stick to the no marks have fallen off, because otherwise it's up to the examiner. That is a very good point. In real life, I'd say you're 100% correct. But yeah. Again, Beth, so she captured a sample of 80, so we do 80 out of the total. Equals, and then again, 10 out of 80. So we can make our lives easier by just crossing out the ones there. So then x is just equal to 80 times 8 over 1. So it's just 80 times 8, and you'll be done. So 640. And again, write down any assumptions. None of the marks have fallen off. So anything that you write to imply that the marks are no longer there, so they could fade, they could be washed off, rubbed off, whatever, it's all fine. So none of the marks have fallen off. Okay. So I think this is kind of okay so far. Does anyone want me to do the last one, or should we just get into like doing the next one? It's probably okay just to go into the normal lesson. Okay, so this was the proof question. I apologise for how this is written. Basically, we had the papers, but I didn't have a scanned copy of it, so I just wrote down the question in preparation for this lesson. So it says, show that 2m plus 1 squared minus 2n minus 1 squared is equal to 4m plus n, m minus n plus 1. And honestly, I would like to just see if any of you would know how to kind of approach this straight away. So what do you think, Evie? Is that easy or hard? Or at least somewhat interesting, maybe? Easy. Really? So what would you do out of curiosity? Okay, not bad. Difference of two... Okay. Interesting. So, probably the fastest way to do this, and this was a 3-mark question, is to use the difference of two squares. So, can you see that we have a square number minus a square number? Okay. So that's the difference of two squares. So if I call this whole thing x and this whole thing y, I basically just have x squared minus y squared. Where if you do a difference of two squares now, you just have x plus y, x minus y. Fair enough. Fair enough. Okay. I thought that might be somewhat interesting for you, but apparently it's not enough to defeat Evie. And again, do the same thing for the other ones. The only thing that I saw would probably be a mistake is when you subtract y, you'd have to do minus 2n, but then it's plus 1 because the minus and the minus becomes plus. Other than that, I think this is fairly okay. So 2m plus 2n, and then you have 2m minus 2n plus 2. So from each of these brackets, you can factorize out a 2. So 2, and then also 2 here, which, if you write that out properly, it should be 4 n plus n, n minus n plus 1. Perfect. There was a part B, which was like a 1-marker, where it said that, who was it? It was like, Sarah says that this whole thing proves that the difference of if you square two odd numbers and take the difference, it's always a multiple of 4. Is she correct? And the answer would be yes, because 2n plus 1 and 2n minus 1 represent just any random two odd numbers, square minus them. So yeah, not bad. Okay, fair enough. This type of question, although it might look a bit easy, and I'm not going to deny it's not the hardest, I find that a lot of students kind of not always get the full marks on it. That doesn't make much sense. So for something like this, where it says Martin wants to find out how often students use the local tram service, he uses this question on the questionnaire. How often do you use the local tram service? A little, sometimes, and a lot. Write down 2 things. Good, that's one thing. So it's not numerical, right? A little, slash, a lot, slash, sometimes is subjective. You can also say it's not quantitative. That's very good. The next mark, not quite. So if it varies with time. So yeah, that's the first mark. The second mark, for the second thing that's wrong, what would you say? So you said if it varies with time. Not exactly. I'd say not exactly with that. You want a hint? Okay, it's something to do with like the frequency here. So this is a little, sometimes a lot, which I know we've said like we want it to be like a number thing, but there's one option that's missing. Never. Good. There's no option for not using the tram. So of course, if you were designing this, which is exactly what we need to do here for another 2 marks, is you would... The question's fine, right? How often do you use it? Rip the paper and walk off, yeah. So how often... Blah, 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 right? That's fine. The question's okay. But in terms of the boxes, you probably want to do something like... instead of how often, this is another thing you could have said. How many times do you use it in a week or a month? Right? So, instead of saying that, so maybe how many times do you use, oh God, tram each week? I'm writing this like a caveman intentionally because, you know, the point is the actual thing. So how many times do you use it each week? And then you could have something like 0 to 2, 3 to 4, 5 to 6, and then maybe something like 7 plus. That would be a much better question, although I've kind of skewed it along, so it's somewhere along here. That would be a better questionnaire because it gives you an actual numerical set of data. So cumulative frequency isn't a estimate, but if you were estimating something like the median or the median, then it would be an estimate because of the reason that you just said. You don't know where the people sit in the class. The reason why cumulative, So the reason why cumulative frequency isn't, exactly. Okay, perfect. You get it. Nice. But you are 100% correct in that. So for those of you that have just joined, if you're here for the recapture stuff, I can go back to it. We did it already, but I can go back to it if you'd like. Just for those of you that have just joined. Okay. This is a really good question. Okay. If you're doing a frequency diagram, you plot it in the middle of the class boundaries. With cumulative frequency, you plot it at the end of the class. Because it's up to the end, right? If you think about it. So if it's 0 to 10 is cumulative frequency of 10, it means 0 to 10 is cumulative frequency of 6, then you plot it at 10, 6. Because it's at the end, yeah. Okay. So it seems like no one wants to do the capture stuff. That's fine. Again, we have one more of these kind of circle theorem proofy type questions, which, you know, could be a bit interesting. First thing you want to do is work out the size of angle BCD. So you want to label where BCD is. So we can call it x or something like that. And then from there, we've kind of dealt with this kind of shape before. 65. Well, that was really quick. I don't even know what the answer is, but let's have a look. We'll see if you're correct. Yeah, so with these kinds of questions, we've done them a couple of times before, and they're always the same. So these things are both... It's a radius meeting a tangent, which means it must be 90 degrees. This whole shape is a big four-sided shape, so if we just do 360 minus 90 minus 90 minus 50, we get 130 degrees. And then Evie, you're 100% right, well done. Angles at the circumference are half that at the centre, so then x is just equal to 65. Again, you need to give reasons. So 65 degrees, because angles subtended at the centre are twice that at the circumference. Where do we get 130 from? Angles in a quadrilateral add up to 360. That will give you the full 4 marks for this. Because you have 2 steps, and you have 2 reasons. Nice and easy. So again, for those of you that have just joined, if you're here for the capture recapture stuff, we've done it a bit earlier on in the lesson, and we found it a bit easy, but if you want me to go back to it, I'll go back to it and do a couple of questions just to explain it one more time. Yeah. Yes. Oh, in terms of this, in the actual question itself, like if I said that this was like 120 or something, you can still get the marks for having the correct reasoning. Sure, we can go back. So we did a couple of capture recapture questions, but they're all the same. So I'm just going to start from this one. So with capture recapture, all you're going to do is you're going to follow this exact method every single time. And with the part B, where it says, I'm going to label this as part B, just to separate it a bit, it's always the same answer too. So it's very kind of formulaic. There's just a strict method. So what you do is it says she catches a sample of 70 birds. So the first thing you write is whatever the sample is, you write that down and you put it over X. The reason why you do this is because she's caught 70 out of a total number of birds, but I don't know what the total number is. That's just going to be X. Okay? So as a fraction or as a proportion, she's got 70 out of X birds. Okay? The next day, she marks them all with a tag, okay? The next day she catches a sample of 60 and 12 have been tagged. So 70 birds have been tagged out of the total, and then when we take a sample, only 12 out of 60 are tagged. Does that step make sense so far? So here we have the fraction of the total birds that have been tagged, and here we have the fraction of the birds in the sample that have been tagged. Those proportions should be equal to each other. Perfect. Oh, hello, Lila. So then all we're doing is rearranging for x. So x is just equal to 60 times 70 over 12. Which, honestly, you can do this in your head. But I am being a bit lazy. I could use a calculator for this as well. But, 6 times 7 is 42. Add the 2 zeros, so you have 4,200 over 12. And then you can keep halving it. So I'll do one fully, and then the rest of them I'll just do it later. Okay, and then you can keep going like that until you get to one that you can't do. And then 1050 over 3 is just 350 birds. This is actually how people do things in the real world too. Like if they want to count how many wolves are in a population or something, it's hard to get them to stand in a line and let you count them. Same with fish. They're not very cooperative. So instead you have to do these kind of fancy things. Now with the assumption is always the same. You're assuming none of the tags have been removed, if you like. You can use that assumption every single time. So when I say removed, they could have fallen off, they could have rubbed off, they could have washed off or anything. You can write those if they make sense in the context. I would just say removed or lost or fallen off. Okay? It's always the same. You'll always get the full marks for this. Alia, Lila, are you okay with this? I'll do one more question, and if you are completely fine with it, we'll continue with the hard stuff we were doing just now, like the more interesting questions. Not that this isn't hard. I mean, like, you know what I mean. Any questions at all? Thank you. Perfect. Okay, cool. So let's do another one then, just to make sure we're completely fine. Yes, you can do that. Yeah, that's fine. You'll get the same answer if you do that, Lila. It's the same way of doing the same thing, right? Because 70 over 12 would get that, yeah. But that's totally fine. So we have Safua wants to estimate the number of deer in a forest. He catches a sample of 40 deer. So the first thing I do is I take this 40 out of the total number of deer. Cool. He tags them, then releases them back in the forest. The following week, he tables a second sample of deer. Tables, interesting. Okay. So his sample is 40 and 5 have been tagged. So 5 over 40. Okay. If this was non-calculator, what I'll do is I'll do 40 over x, and I'd simplify that fraction on the right-hand side, sorry. 5 over 40, which is just 1 over 8. So then x is just going to equal 40 times 8 over 1. So it's just 40 times 8, which is 320. Yeah, true. A ratio might be better for that. But whatever is your preferred method, this is a way to do it though. However you want to solve it. So doing a ratio does work as well. So working out what this number has to be to make it the same. So you can times the top one by 8, and you should get that, and things like that. That works as well. And the assumption again, no tags have fallen off or been removed. It doesn't matter what random situation they give you, you can always say the assumption is no tags have been removed, and they can't mark you down for it because that is an assumption. Always. You can never guarantee that the tags have stayed on. So are we all okay to move on from that? Every question is identical really on this, just different situations, but the method is all the same. Oh. Cool. So we did a couple of these questions. Let's go over. This one, honestly, I wasn't sure if you'd find this easy or hard, to be honest. But it says there's a diagram showing a solid metal cylinder, which a radius of 2x and a height of 9x. And the cylinder's melted down and made into a sphere of radius r. Evie's already said easy. That's fantastic. So the idea here is that you should know that they will have equal volumes, right? So the volume of the cylinder equals the volume of the sphere. Because if you think about it, volume is just, in this case, is how much material the cylinder's made of. And they've made it into a sphere, so that should have the exact same amount of material in it, if you'd like to think of it that way. So you're right. Volume of a cylinder, all you do is you work out the area and you times it by the height. So the area is a circle, so it's pi r squared times height. For a sphere, the volume is just, let's do sphere, 4 over 3 pi r cubed. So all you're doing is essentially equating them. Okay? So volume of a cylinder, we have pi, r is 2x squared, times the height, which is 9x. And the sphere, we don't actually know much about it. It's just 4 over 3 pi r cubed. So immediately I'm just going to cancel out the pi's. And we should have r equals something, because it says find an expression for r in terms of x. Cool. So 2x squared makes 4x squared, multiplied by 9x, equals 4 over 3. Oops, not pi. Whoops. R cubed. The 4's can actually cancel out on both sides. Makes our life a little bit easier. And we could also cancel, actually we can't cancel the 9, but I'll show you. So x squared times 9x would give me 9x cubed equals 1 over 3 r cubed. Kind of scuff that, sorry. Times both sides by 3, we get 27 x cubed equals r cubed. You're just going to take the cube root. Cube root of 27 is 3, cube root of x is x, and that's r. So r is just equal to 3x. So if you ever want to melt down a cylinder and make a, sphere, you can have a relationship between the radius of the cylinder and its sphere. 3 marks. Bit harsh, to be honest. I think it should be worth a bit more, but hopefully not too bad. Moving swiftly on. This one, it looks quite simple, and I'm not going to lie to you, it's not the worst one in the world, but this kind of probability question does kind of screw people over quite a lot. So I thought this would be kind of interesting to do. I mean, the thing is, it's easy, but it's also easy to actually make a mistake on this. Very easy to make a mistake on this. So keep that in mind. So, if you'd like, you can have a go at it quickly. I'll give you a couple minutes. Or maybe I'll just... Yes, like your spinner question, yeah. So, the first thing I do in any probability question is I write down what probabilities I need. So it says here the probability that the 2 biscuits are not the same. So how many different ways can I have this? Well, if I call plain biscuits P, chocolate biscuits C, and ginger biscuits G, I could get a plain followed by a chocolate. I could get a chocolate followed by a plain. I could get a plain followed by a ginger. I could get a ginger followed by a plain. I could also get a chocolate and a ginger. Is there any that I've missed? Or a ginger and then a chocolate. So yeah, there are 3 options out of 2, so there should be 6 combinations, okay? Now this might look a bit intimidating, but a lot of these probabilities are going to be the same, which is handy. But does everyone understand where I got that from? As a bit of a... if you guys know what the product rule for counting is, you should be able to work out that you should have 6 combinations just like this. Because there's 3 options, and there's 2 spaces that they can take, so 3 times 2 is 6, I should have 6 possible outcomes. Okay, cool. Perfect. So what I'm basically going to do is the probability that they're not the same type is you take the probability of PC plus CP plus PG plus GP plus CG plus GC. Okay, so let's work them out individually. And you'll find that there should be some that are duplicates. Now that I've said that, I really hope that that's the case. So what's the probability of getting a plain biscuit at first? Well, 12 out of 20, right? Because there are 12 plain biscuits and there are 20 biscuits in total. Then getting a chocolate, well, there are 5 chocolate biscuits left, but there's only 19 biscuits after that, right? Because you've already taken 1 out. Plus CP. So chocolate first would be 5 over 20 times the plain, which is 12 over 19 now. So if I show you this, so this question is from, I think it's a 2010 paper or something like that, or 2009, it's one of those two. This is a bit brutal, but can you see that these 2 things are actually going to be the same fraction? So I only need to work out one of them and double it. Because it's completely commutative, right? I can just swap the numbers around. Yeah, so that's the method on how to actually make this faster, is you only actually need to work out 3 probabilities and add them. But if you didn't know that, you would work out 6. Oh yeah, well done, perfect. So I'm going through it a bit slower just to be super, words are really hard for me today. Just super in depth through it. But again, you're going to find that these next 2 probabilities are also the same. So it'd actually be 3 over 20. If you're not sure why, just let me know and I'll go into it in a bit more detail. So then CG, so we've got 5 over 20 times G is ginger, so 3 over 19. Okay. And So again, every pair is actually the same probability. So I'm only going to work out one of them, if that makes sense. So if I work out this one, I just need to double whatever it is. So 12 times 5 is 70, so it's going to be 2 times 70. 20 times 19, well 20 times 20 is 400, so it should be 380. I'm pretty sure. And the same one, so 12 times 3 is 36, yeah, goodness gracious, over 380. Plus 2 times, so that's these two done. And the last one's 5 times 3 is nice and easy, 15 over 380. So I've done this in a fairly slow way just to make sure that everyone's on the same page. 140 over 380 plus 72 over 380 plus 30 over 380 would give you, so 70 plus 30 is 102, so that'd be 242 over 380. And the good thing is, we better get the 70. Okay, 12 times 5 is 60. Good Lord, you're right. That's what I get for being... Please let me delete this. Alright, you're right, it's 60. That's embarrassing. I mean, I did that on purpose to see if you guys are paying attention. So well done, Evie, you're paying attention? Yeah, that looks dreadful now. No, 120. Now it's fine. 122 then. 122? Oh my goodness, hold on. 222. Let's chill. To be fair, if I was doing this in an exam, I would actually work this out a bit more precisely than that. So, Evie, like you said, hope you're not like that tomorrow. Be more precise than I am. Like, literally use column method for everything if you have to. Because, Jesus Christ. Okay. I was so hyped that I managed to get the 380. I couldn't do 12 times 5. Okay. Okay, cool. Now it's correct. And again, you can always make sure that your answer is somewhat correct by seeing that it's less than 1, right? Okay. It's kind of... That's the same question. Interesting. How can you prove your answers with algebra? It depends on... Wait, as in an algebra question? Or like using algebra, how do you prove it? Want to check... Honestly, it's a bit tricky. If it's a rearranging question, it's fairly tricky to do. But if it's like factorizing, then obviously you can expand. What kind of question? Like simultaneous equations or something? I think you probably know that already, how to check that. But yeah, like what? Like if you're simplifying or something. Like recipe questions. So in some cases with maths, in order to prove your answer, what you need to do is basically just redo the question. But what my recommendation is, yeah. Oh, when there's no variables. Okay. So yeah, if you have to do that, like for example, when I did 12 times 5 and I messed up and got 70 somehow, if I were in an exam and I wanted to test that, I would actually do the reverse calculation. So the problem is that if I was reading this to check my answer, I could say, 12 times 5, yeah, that equals 70. That's the problem. Your brain like auto-corrects it yourself. So I would actually do the calculation backwards. So I'd either do 70 divided by 5, that doesn't equal 12, right, equals 14. So then I know I've done something wrong. Like try and work backwards with it. So if you're timesing two numbers, maybe divide them instead. Like divide the answer and see if you get the question right. Because it prevents your brain from actually being able to kind of auto-correct yourself. That's one kind of tip, yeah. I'm not going to lie, it's hard to check your answers sometimes. But repeating the question but trying to do a different method can also work as well. but sometimes you don't know multiple methods, which is fine. It is a bit tricky to do, I'm not going to lie. Okay, we have a couple more. Okay, cool. Damn, have we got 2 more questions? Yikes. Okay, I'll have to find some more. This one might be somewhat interesting, maybe? Possibly? So we have to work out the area of the shaded shape. So again, with something like this, the way I would approach it is, I would just think, what would you mean no? Like, do you want to like try, or is it not easy? Or not hard? So with something like this, if I just go through the, like, not even the first step, not interesting, not hard, okay. So with something like this, all I'd do is I'd say, well, in order to work out the shaded region, I need to take this big square, so the area of the square, and then I'm just subtracting the 2 triangles, right? So that should be fairly easy. In order to work out the different sides, I thought this might be somewhat... basically, when you look at these old questions, some of this style haven't appeared since then, so it can be somewhat... It can throw some people off. It says M is the midpoint of CB, so if this total length is 12, then this length here is 6 centimeters. And AN is a quarter of AB, so as Evie just said, that means it's a quarter of 12 here, so that's 3, and this one's 9. So now you have the area of the 2 triangles too. So the area of the square is 12 times 12. And then you're subtracting half base times height, so 12 times 3. For this top one here. And then subtracting another half, 6 times 9. Yeah, perfect, well done. That's a 6-mark question, by the way. Stop. Oh, you didn't do a half. Interesting. That's a 6-mark question. So I don't think it's too bad. So a half times 12 is 6. 6 times 3 is 18. And minus another half. Half times 6 is 3. 3 times 9 is 27. So you've got 144 minus 18 minus 27. Okay. I can't remember if this was a non-calculator or calculator paper. What feeling is non-calculator? So 18 and 27 make 45. Yes, that's 45. So 144 minus 45 would be 99 centimeters squared. Not bad for 6 marks, eh? Not bad at all. Okay. Any questions about that so far? What I can do, because I'm definitely going to run out of questions, is I can find some more. Okay. I've got a feeling you guys might find this pretty easy. Well, it depends on how well you know your circle theorems. Because again, we have a circle, so you always think in circle theorems. You'll find me one. Oh dear. You're going to find out I'm a fraud. I was looking at mark schemes. Okay. For this one, hopefully you can see. So we're looking for angle BAD, which is this, which, as Evie pointed out, ABCD is a cyclic quadrilateral, or cyclic quadrilateral, however you pronounce it, because all 4 corners are on the circumference. So this inside bit is not a cyclic quadrilateral, just this outside bit. And as you may know, opposite angles, so opposite angles in a cyclic quadrilateral add to 180. So all we do is 180 minus 130, which is 50 degrees. Nice and easy, hopefully. Too bad. With circle theorems, it can be kind of hard to remember all of them, especially when you don't use them that much. I wouldn't really recommend memorizing them, because memorizing them isn't very useful. The useful thing is knowing how to use them, so I just practice as much as possible. ODC, so that's actually this angle here, Evie. ODC. So you can use that, yeah. So if I put this as 50, then this is 100. Yeah, because again, angles at the centre are twice that circumference. Subtended at. I was actually thinking of something slightly different, but yeah. So the thing I was thinking of doing is just drawing a line here, and then this is our isosceles triangle. So then you can just kind of split it up, if that makes sense. So this would just be 180 minus 130, which is 50. Then divide it by 2 to get 25. And then, because we've cut this angle in half, although it doesn't look like half because I can't draw to save my life, we can just double it. Okay. Nice and easy. And that's a 4-mark question. Question 14 of the higher 2017. Is that AQA, Alia? I'll get it up now. Question 14, 2017, paper 1. Assuming it's AQA. Alia, is it AQA or Edexcel or something? Just to make sure I get the right question. Ah, Edexcel. Okay, there we are. Okay. I'll have definitely got the wrong one then. Okay, Edexcel. 2017, paper 1, question 14. So let's have a look-see. Okay, this could be interesting. Let me just get the snipping thing up. My bad. Sorry if the screen went weird for a second. It kind of whites out when you do that. Okay. So that's the question. You guys are free to kind of go through it for a second. What's that here? Okay. Perfectamundo.
What?
Whoops. There we are. That was close. Okay. Make first equal 1. So y plus x equals 1. Oh, I see what you mean. So y plus x. So you divide both sides by this, and then you can make it that. Okay. Yeah. So the first step. Well done, Evie. Jesus, I didn't even get a chance to do it. So if you have the ratio y plus x to y minus x, because they tell me here that it's k to 1, I just realised how much the latency is on this. Jesus. All right. K to 1. We want to get everything off of the right-hand side of this ratio, because we want to have 1 on the right-hand side so we know what k is. Okay. So I want to divide both sides by y minus x. So we get y plus x so the cheat method is to essentially do it backwards, where you start from this, as far as I'm aware. So you start from this and you rearrange it to get this, which is something you can do. Okay. So what I know is all of this is equal to k. So we have k equals y plus x over y minus x. Like that. Oh, this might be another case where Evie knows the method and I don't. But yeah, like k to 1 equals the other. Interesting. Let me go through it and let me see if I can work that out. So now all we're doing, by the way, is rearranging for y, because that's what it is here. So this is just a making the subject question. So times both sides by y minus x. Ali, is there anything so far that doesn't make sense? Oh, I see what you mean now, Evie. Yeah. Okay, I think the cheat method is that you kind of skip this initial step and you jump straight to this, because you know that it's always going to be the same, right? Because you know it's to 1, so you can just flip it over there. All good? Perfect. So I'm going to draw a line down here. I'm going to continue from up here, so I'm just going to write the exact same thing again. And yeah, so when you do a kind of make the subject question, there's proof, really? Okay. So yeah, if you want to do a rearranging thing, all you need to do is move all of the y's to one side, all of the other stuff to the other side, because again we want y equals. So I'm going to move the y to this side and the kx to the other side. I'm going to do this by minusing y and plussing kx. So we get ky minus y equals y plus x plus kx. Sorry, no, not y. Jeez, I made a mistake there. Just x plus kx. Okay. Factorize out the y. Divide both sides. So all I did here is divide by k minus 1. And then all they've done is factorized out the x. So you get x 1 plus... they wrote it the other way around. Okay, I'll write it the other way around as well. And that would be it for the 3 marks. But there is a proof, like you can actually work it out. And it causes them to flip. Okay. You're welcome, Alia. Oh! Yeah, I remember that. Okay. I think I remember what you that method. Okay. That does make sense. Yeah. I don't think this is that long though. But yeah. Fair enough. Fair enough. Interesting. Does make sense. So while I'm here, what I could do is... Let's see if I can find some more ancient... Actually, I think I did go through the papers and they just weren't very interesting. Like, they got kind of easy ages ago. Kinda. In fact, yeah, once you go too far back, it's like too easy. Yeah, that's fine. So if I look at if I open up the mark scheme quickly, and I scroll down, here's the mark scheme for it, right? So it kind of looks like they do a similar thing to what you did, right? So they multiply both sides to make it equal to this, and then you get that. So it's a somewhat similar method to what you're talking about, where they kind of just jump straight to the bit where it says 3x equals 4y in your example, and that's fine. I think that's why these questions can be a bit tricky for people that haven't done it before, because the method, I mean, the mark scheme sucks. It doesn't tell you how to do it at all. So yeah, I think, yeah, you get the exact same marks. 2018 so easy. Yeah. But the thing is, I think when you go further back, it gets harder, but then it gets easier as well. Like, back to like all the way to 2020. Like, it's a bit of a curve. Like, I'm looking at the 2010 papers right now, and they were easy. Why can you cross multiply ratios? So, let me write it out. I'm trying to think of the way to kind of put this. So when, like for example, with what you wrote 4 over x, and you did the same thing with 3 over y, right? How do I put this? To be honest, it's not my preferred method, and essentially, it's not my preferred method because I didn't like fully understand it, if that makes sense. Like, you'll get what I mean more when you go into like A level, for example. Is there's certain methods to do questions that they're basically like tricks, but exactly that's what I mean, Evie. So the problem with that is that the actual proof behind it might be really, really advanced, but then people are saying, oh, you can just use this trick. I personally don't like doing that because I can't teach it as well. The only reason why I can teach relatively well is because I understand what I'm teaching. But with that method, like the maths behind it isn't the most intuitive. So I kind of avoid it. But if you go on like TikTok or Instagram or whatever, you'll see these people that like show really weird tricks for like multiplying huge numbers or integrating certain things or something like that, or doing certain trig ratios. And they're tricks, but they don't work for every case, and they also have like a lot of advanced stuff behind it. And the problem is when you don't understand something, it's hard to remember. Yeah, I mean, that's probably a good method to approach it. But I see a lot of these things on like Instagram Reels and stuff where they show like, for example, the tabular method for factorizing quadratics. Like there's this guy that like did it, and everyone in the comments is like, but why does it work? I don't get it. So it's like, yeah, okay, the trick works, but you don't understand it. So it's kind of, I don't know. It's weird. I don't like it that much personally. Doing stuff like that. Does EM waves move through vibrating magnetic electric fields? Yeah, that's exactly right. I like how there's just random physics questions just thrown in there. I'm going to try and find another kind of interesting question for you guys. I'm going to move this over here because we don't need that anymore. It's literally lit because it's an electromagnetic wave, right? Calculate the size of... Ooh, is this interesting? You know, we've actually done this many times before, so it's not like... The thing is, even like the hard questions that I'm finding, we've actually done them before in previous lessons. And they're ones you guys found hard, but you probably won't find hard now, but... It's kind of interesting, like with circle theorems and stuff. Was that an... You know what? There was something with ratios that might be interesting for you guys. No, they don't only do that. So main sequence stars fuse hydrogen into helium. But for example, with like a red giant, it will fuse helium into oxygen? Nitrogen, sorry. Yeah, that's correct. So main sequence stars aren't hot enough normally to burn helium, so they don't. So when it runs out of hydrogen, what happens is there's nothing holding the star up, so it starts to contract. And as it contracts, it gets hotter and hotter and hotter until it can fuse helium, and then it explodes outwards. Oh man. No worries. Okay, with the questions, there is some stuff with ratios, like joining them. I did not take the heat into account. Yeah. So okay, give me 1 second. I'm gonna find this quickly. No, that's not good. This one. This is fine. I think you're okay with recurring decimals. I'm just straight up showing you my tuition lessons now, by the way. Okay. This is fine. You'll be fine with that. Actually, these aren't as hard as I thought they would be. Okay. Okay, fine. This one might be an interesting one for you to do. Potentially. Yeah, no, for free. These guys pay for the lesson, and I'm just giving it to you guys for free. Yeah, I don't know if this would be too useful. How do you find these kinds of ratio questions? Easy. Fair enough. Essentially, so there are two types of ratio questions. One where they have like A, B, and then B, C. So they have a common letter, so you can just join them together by making the numbers the same. But the method for this, these confuse you. Yeah, honestly, these are hard. So this is probably the hardest ratios can get in terms of like the general base layout. So normally they might say something like, oh, A to B is 2 to 1 and B to C is 2 to 3. What is A to B to C, right? And all you need to do is make the B number the same because they're common, right? In this question though, they've done something different. They have nothing in common. So we have red to not red is 2 to 3. And then we also have green to not green, which is 6 to 19. So can you see there's nothing in common between them? So working out the ratio of red to blue to green is somewhat more involved. However, I'll show you the trick that you're meant to use. And it's super, super easy. All you need to do is look at the total number of parts. The total number of parts for red to not red, 2 to 3, is just 5 because 2 plus 3. Total number of parts for green to not green is 25 because of 6 plus 19. Okay? All you want to do is make the total number of parts the same. Okay? But generally you just want to times up. You don't ever want to divide because that can give you fractions and fractions suck. So let's just times up. So to get from 5 to 25, I want to times by 5. That means I'm going to times both sides of my ratio by 5. So now my red to not red is now 10 to 15. Okay? And then we still have the exact same thing for green to not green. So, we're quite lucky. If we want the red to blue to green, I actually already have red and green. Red is 10 and green is 6. Okay? So in terms of blue, well, blue is just going to be whatever's left over, right? So in total I have 25 parts. 10 of them are red, 6 of them are green. So 25 minus 10 minus 6. So that's 15 minus 6, which is 9. So the ratio at the end is just 10 to 9 to 6.